Imagine for a moment that you just spent, I don't know, maybe $5,000 on the most elite, industry-standard 3D drafting software available on the market today.
Right, the really high-end stuff.
Exactly. And you buy the absolute best workstation to run it. You spend 3 weeks meticulously clicking menus, defining all these geometries, and designing this brightly colored, mathematically flawless plastic toy helicopter.
Sounds like a pretty standard Tuesday in product development.
Yeah. So you send the file off, you manufacture a physical prototype, and you finally hand it to a 3-year-old child. And because you designed it for the vacuum of a computer monitor instead of the absolute chaos of a playroom, that child drops it on a hardwood floor.
Oh, no.
And it shatters into 4 dangerous, jagged pieces in exactly 4 seconds.
It is a devastating scenario, but I mean, it happens every single day across pretty much every industry.
It really does.
We have this deep-seated psychological flaw, I think, where we desperately want to believe that competence is something you can just purchase with a software subscription. We think the tool itself is the magic bullet.
We really do. We love that illusion, the illusion that the tool equals the talent.
Yeah, absolutely.
It's like if you buy the carbon fiber running shoes, you think you're suddenly a marathon runner. Or if you download the enterprise-level video editing suite, boom, you are a filmmaker.
Right, but then you step into the real world.
Exactly. You step into the real world of complex design, whether that is engineering a physical product or like writing code, and that comforting illusion just shatters, just like that toy helicopter. You can have the most powerful software on the planet, but if you don't have the foundational thinking to support it, you are just going to generate high-definition garbage.
High-definition garbage. That's a great way to put it, because the tool only amplifies what you already bring to the table. If you bring rigorous structured logic, it amplifies your genius. But if you bring chaos and vague intentions, it will amplify that chaos until it becomes a massive liability.
Okay, let's unpack this, because that fundamental friction between the tool and the talent is the core mission of our deep dive today. And we are looking at a stack of sources that, well, on the surface, they seem to belong in completely different universes.
They really do.
Yeah, like we have a set of highly specific battle-tested guidelines for CAD engineers. And for those listening, that's computer-aided design and drafting, the people who actually build the physical world.
Right, the hardware people.
Right. But then we have an incredibly dense, almost intimidating guide to elite AI prompt engineering, specifically for large language models.
The software side. The very, very cutting-edge software side.
Exactly. And finally, bridging these two wildly different worlds, we have a radical operating framework based on the philosophy of the legendary 20th century industrial designer Dieter Rams.
It is a phenomenal collection of materials because, while one source is talking about physical geometry and manufacturing tolerances and injection molding,
and the other is talking about neural networks, attention mechanisms, and token limits, they are fundamentally having the exact same conversation.
They really are. And that conversation, our mission for you, the listener, as we go on this journey today, is exploring the concept of intentionality.
Intentionality, yes.
Because whether you are designing a physical product that a human being is going to hold in their hands, or you are writing a prompt for an artificial intelligence to, generate some massive corporate workflow, mastering the interface of your software does not mean you know how to design.
No, not at all. Design happens long before you ever click a mouse or open a laptop or type a single keystroke. The software is, it's merely the execution phase of a much deeper cognitive process.
There is a quote from the CAD engineering sources that just hit me like a ton of bricks. It perfectly sets the stage for everything we are going to explore.
Oh, I know the one you're talking about. Yeah, the author, this engineer with decades of experience in new product development, writes this: most CAD models fail before they are even drawn, not because of bad software, because of bad thinking.
What's fascinating here is the absolute certainty of that statement. Fail before they are even drawn.
Right, it's so definitive.
Today's deep dive is really about identifying and systematically stripping away that bad thinking. We need to look at how that bad thinking manifests in physical engineering, how it translates into creating absolute digital waste in AI environments, and most importantly, the mental frameworks we absolutely must adopt to fix it.
So let's start with the physical world. Let's start with the CAD engineers and the really rigorous world of new product development. The premise laid out in these sources is beautifully blunt and, frankly, a little offensive to anyone who prides themselves on knowing all their software shortcuts.
Oh, it definitely bruises some egos.
For sure. The text states, design is not what you draw. Design is what you understand.
And that is the defining line between a technician and an actual designer. A technician knows where every drop-down menu is located, right? They know the keyboard shortcuts to extrude a shape or bevel an edge.
They're fast in the software.
Exactly, they're fast. A designer, on the other hand, understands the human friction they are trying to solve in the real world.
I like to think about it in terms of, like, writing a novel. I could go out and buy a vintage refurbished typewriter
Yeah.
or the most expensive, distraction-free digital word processor on the market.
The ones that cost like $1,000 for just a screen and a keyboard?
Right. But sitting in front of a fancy keyboard does not make me a best-selling author. Rushing to open the CAD software before you've done the mental heavy lifting is the equivalent of staring at a blank page without an outline, without character development, without a plot, and just hoping a brilliant story magically falls out of your fingers because the font looks nice.
It is the trap of premature precision.
Premature precision. I love that phrase.
When you open CAD software, the interface immediately demands exactness. It asks you for coordinates, dimensions, angles, material densities. If you haven't actually solved the core problem yet, the software forces you to make permanent decisions about a flawed concept.
Because you have to plug a number into the box.
Yes, you have to type something. And the source material doesn't just leave us with that philosophical warning, it provides an exhaustive 5-step framework for how to build that mental outline before you ever touch the tool. And they use a very grounding example to walk us through it, which is building a physical toy.
A simple toy. So let's walk through these 5 steps of design thinking, because I want you, the listener, to actively apply this to whatever you build in your own career, whether that is a marketing strategy, a piece of code, or a legal brief.
It applies to everything.
It really does. Step 1 in the CAD process is simply empathize. The text says that before you draw a single line of geometry, you have to ask the hard, uncomfortable questions. Who is this toy actually for? How will they use it? And my absolute favorite question, where will it break?
Where will it break is the question that separates amateurs from professionals. Most novice engineers fall victim to what we call the happy path fallacy.
That's happy path. Right.
They envision their product functioning perfectly on a sunny day, used by a rational consumer who actually reads the instruction manual.
Which nobody ever does.
Never. But empathy in design means anticipating the brutal reality of human behavior.
The chaos of the real world.
Precisely. If we are designing a toy for a toddler, that object is not going to be placed gently on a display shelf. It is going to be thrown down a flight of stairs. It is going to be stepped on by a parent in the dark.
Barefoot.
Barefoot, yes. It is going to be chewed on, submerged in bath water, and left out in the baking sun. Empathy means understanding the kinetic stress the object will endure.
And if you don't do that?
If you don't empathize with that reality during step 1, the source is clear on the consequence. Your model will look stunningly perfect in the digital rendering, but it will fail structurally the very moment it meets the real world.
Which brings us to step 2, define. Once you have empathized with the chaos, you have to decide what problem you are actually solving. And the author makes a brilliant, vital distinction here between a vague problem and a precise problem.
Vague problems are the silent killers of new product development. They really are.
The source notes that a vague problem is, walking into a meeting and saying, I want to make a cool toy. Well, what does cool mean?
That means nothing.
Exactly. It's entirely subjective and unquantifiable. You cannot engineer cool. A precise problem is saying, make a toy that is easy for a 3-year-old to hold, or make a toy that will not shatter into pieces smaller than a choke tube cylinder when dropped from a height of 6 feet.
If we connect this to the bigger picture, this is where massive corporate initiatives go completely off the rails.
Oh, absolutely.
The stakeholders never define a precise problem. They just issue a vague directive like, optimize the workflow or enhance the user experience.
Synergize the deliverables.
Exactly. And as the CAD source points out, if the problem is vague, the resulting design will inevitably be confused. You are essentially asking your engineers to solve a mystery without telling them what the crime is.
Okay, so we have empathized with the destructive toddler, and we have defined precise constraints. It must fit in a small hand, and it must survive a 6-foot drop.
Right.
Step 3 is Ideate. Now, wait a minute. I have to push back here. If I am a trained CAD engineer and I finally have my precise parameters, isn't this the exact moment I should fire up my expensive software and start modeling?
No. That is the ultimate temptation, and the text explicitly flags it as the most common catastrophic error in the entire workflow.
Really?
Yes, this is the moment you must actively resist the tool.
But why? I mean, I know my dimensions, I know my drop height constraint. Why can't I just draw the thing?
Because, as we touched on earlier, software demands rigidity. In the Ideate stage, you do not want rigidity, you need absolute unconstrained fluidity. This stage is for sketching on the back of a napkin. It is for building things out of cardboard and duct tape. It is for deliberately breaking your own assumptions. If you start defining complex polygons in a digital matrix, you become emotionally attached to the time it took to build them.
That is so true. The sunk cost fallacy.
Exactly.
Right.
You won't want to throw the design away because it took you 4 hours to render the lighting.
That makes so much sense. The text actually has this wonderful line, bad ideas are explicitly useful here. They clear the path. I love the concept that you have to actively generate terrible designs just to flush them out of your cognitive system.
It is a process of mapping the negative space. You sketch the toy with sharp aerodynamic wings, immediately realize those wings will snap off and become a hazard during the drop test, and you discard the idea in 10 seconds.
Right, because it was just a pencil sketch.
Exactly. You sketch a spherical shape, realize it rolls away too easily for a toddler to catch, and you discard it. You are discovering what the product should not be. Doing that with a pencil takes minutes. Trying to discover that through digital modeling takes days.
Which leads us to the reward. Step 4, prototype. I want to frame this exactly how the source frames it because it requires a massive mindset shift. The author says, now you earn the right to open your CAD tool.
Earn the right. That phrasing is so powerful. It fundamentally changes the relationship between the human and the machine.
It really does.
It implies that access to the software is a privilege granted only to those who have suffered through the rigorous, messy thinking beforehand.
You don't just get to boot it up because you pay the monthly subscription fee.
Yeah.
You earn the right through empathy, precise definition, and rapid ideation. But even here in the prototyping phase, the goal is not a polished masterpiece.
No, not at all.
The source says you are building a rough digital version to send to a 3D printer that is, quote, just real enough to fail.
The prototype is not a monument to your genius. It is a sacrificial lamb.
A sacrificial lamb, I love that.
You are bringing it into the physical world specifically to observe the mechanics of its destruction. You want to see if the plastic warps. You want to see if the center of gravity is off. You build it to break it.
And that leads directly to the final phase, step 5, test. You give the design over to reality. You hand the 3D printed model to the toddler. Does it work? Does it break? Does the user struggle to hold it?
And then the hardest part.
Right. Then you take all of that brutal, unfiltered feedback from reality, you swallow your professional pride, and you go back to step 1.
This entire 5-step sequence, empathize, define, ideate, prototype, test, synthesizes a philosophy that extends far beyond mechanical engineering.
Definitely.
The ultimate takeaway from this CAD document is that drafting is not about drawing lines on a grid. It is about translating rigorous thought into a physical object that can survive contact with the real world.
The quote that concludes that section is a masterclass in perspective. Most engineers design for the screen, the good ones design for the hand.
Design for the hand. That is the only valid metric of success. It does not matter how beautifully the lighting reflects off the virtual surface in your software. What matters is how it lives and functions in the physical world.
So, keeping that concept front and center, the failure of designing for the screen instead of the hand, I want to look at how this applies to the digital world.
Let's do it.
Because physical design fail when we don't anticipate the chaos of the toddler. In the digital space, that chaos is artificial intelligence. What happens when we skip this rigorous design thinking and just start typing requests into an AI prompt box?
We trigger an epidemic. We get what the software industry and our sources are now universally referring to as AI slop.
AI slop. It is such a visceral, perfect term. You know exactly what it means the second you hear it.
You can just feel the mediocrity in the word itself.
You really can. I'm looking at the AI blueprint source document here, and it highlights a fascinating paradox in the era of artificial intelligence. Perfectly polished, grammatically flawless content actually fails. Specificity beats the generic every single time.
To understand why this happens, we have to look at the mechanics of a large language model. An LLM's default state, if you do not apply the kind of rigorous CAD-like design thinking we just discussed, is to regress to the statistical mean.
What does that mean, practically?
Well, these models are essentially highly advanced autocomplete engines. They calculate the probability of the next word based on billions of data points. If you give them a vague prompt, they will give you the most average, highly probable, mathematically safe string of words possible.
And that is what slop is.
Yes. It is flawlessly punctuated, completely inoffensive, and utterly devoid of human friction or meaning. It is the digital equivalent of the CAD toy that looks great on screen, but shatters in reality because it wasn't engineered for a specific purpose.
The blueprint provides some incredible examples of this contrast, comparing slop to what they call high-signal truth. For instance, a classic piece of AI slop is starting a memo or an article with the phrase, "In today's fast-paced business landscape."
Ugh, that phrase should be outlawed.
It's everywhere.
It means absolutely nothing. It is a mathematical placeholder. It is the conversational equivalent of elevator music, you know? It fills the silence without offering a single note of value.
Right. Now contrast that with the high-signal truth alternative they provide. I wasted $10,000 on Facebook ads before I figured this out. Instantly I care. Instantly my brain registers that a human being with real skin in the game, who has suffered a real loss, engineered the thought behind this sentence.
It grabs you.
It totally does. Another example of slop they give is the classic listicle intro, 5 tips for better productivity.
It is entirely forgettable because it has been written 10 million times across the internet. The AI gravitates toward it because it is the path of least mathematical resistance.
Versus the high-signal alternative. Everyone says consistency matters, but I post 3 times a week and make 6 figures. That sentence has friction. It challenges an assumption.
It has a specific, verifiable viewpoint.
Yes. It was designed for the human mind, not the algorithm.
And to combat this overwhelming tide of slop, the AI blueprint doesn't just complain about the technology, it offers a highly structured framework. They call it the 5-point depth check.
The 5-point depth check. Let's dig into that.
For anyone listening right now who uses AI to generate emails, project reports, marketing copy, whatever, applying this checklist is non-negotiable if you want your work to survive contact with reality.
Let's go through this 5-point depth check, because it is essentially the test phase of our CAD process applied to digital language.
Yeah.
Point number 1 is the perspective split.
The perspective split.
Before you publish anything an AI wrote, you must read the text, not as yourself, but you force your brain to read it through 3 distinct lenses, as a skeptical CEO, then as a junior employee, and finally as a direct competitor.
This is pure empathy mapping. It forces you out of your own cognitive bias.
How so?
Well, if you read the text from the perspective of the CEO and it feels like unquantifiable fluff, the document fails. If you read it as the junior employee and you are alienated by the dense corporate jargon, it fails.
Right.
And if you read it as your competitor and think, wow, we could have copy-pasted this exact same generic mission statement, then you have absolutely failed to create value.
Point number 2 is the confidence score. You have to isolate every single claim the AI makes in the text and rate it on a scale of 1 to 10 for absolute confidence. And the rule they enforce is ruthless. Anything scoring under a 7 gets deleted immediately, or you must go find a primary human source to back it up.
This step is how you prevent AI hallucinations from destroying your professional reputation.
Because the AI sounds so sure of itself.
An AI will state a complete fabrication with absolute sociopathic confidence. It doesn't know what a fact is. It only knows what words look good next to each other based on its training data.
That's terrifying.
It is. If you do not actively score the claims, you will inevitably publish something that proves you blindly trusted the tool.
Point 3, the specificity audit. This is incredibly simple, but so effective. You literally just count the numbers in the text. The rule is you need at least 3 concrete data points.
3 data points.
Yeah. If you don't have them, the text is too abstract and floating in the clouds. You have to add metrics.
Because numbers anchor the narrative to physical reality. Saying, we had a really strong quarter is slop.
Total slop.
But saying, we increased Q3 user retention by 14.2% while reducing acquisition costs by $2, that is a specific engineered truth.
Point 4 is my absolute favorite, the so what test. You read a paragraph generated by the AI and ask yourself a blunt question. What does the reader actually do with this information?
And if the answer is nothing?
If the answer is nothing, you cut the paragraph. Period. I don't care how beautifully the AI structured the sentence.
That is the principle of utility in action. If a paragraph does not serve a function, if it does not inform a decision or change a perspective, it is drag. It is actively slowing the reader down and disrespecting their time.
And the final point? Point 5 is the comment seed. Before you hit publish or send, you must manually write 3 thoughtful, challenging comments that a real human being might leave in response to the text.
That's interesting.
Yeah, you're preloading the depth and modeling the quality of engagement you expect to receive.
What's fascinating here is that the comment seed acts as a diagnostic tool.
Like a stress test.
Exactly. If you read your AI-generated memo and you cannot think of 3 interesting, provocative comments to make about it, your output is probably just a wall of generic noise. It proves you haven't engineered anything worth discussing.
Okay, so we have identified the disease of AI slop, and we have the diagnostic depth check to catch it. But here's where it gets really interesting. Because when it comes to fixing the root cause, when it comes to how we actually construct the prompts to prevent the slop from generating in the first place, our sources present 2 completely different, intensely opposing philosophies.
Oh, this is the best part of the whole deep dive.
It is. And the first approach we are going to dive into is the maximalist approach. This comes from an incredibly dense document outlining the operational skills of an elite prompt engineer.
Calling it dense is an understatement. This document describes a level of interaction with artificial intelligence that borders on science fiction. It is a masterclass in extreme cognitive load.
Truly. We are talking about engineers who are building single prompts that are 20,000 words long.
It's hard to even wrap your head around.
20,000 words. That is the length of a short novel just in foundational instructions before the AI even completes a task. And the stated goal of this massive architecture is to generate output that is, quote, deeply empathetic, wildly engaging, and indistinguishably human.
Indistinguishably human, that's a high bar.
To achieve this, the text says the elite engineer must embody 3 distinct, highly technical personas.
The sheer scale of effort required here is staggering. Let's break down the first persona they describe, the architect.
The architect.
The architect is responsible for the structural foundation. Writing a 20,000-word prompt is incredibly dangerous because an AI has a limited working memory, which is known as the context window.
Let's pause and explain that because it's vital for anyone listening. The AI can only hold so many tokens or pieces of words in its active brain at one time, right?
Precisely. If you exceed the context window, the AI literally begins to suffer from amnesia.
It just forgets what you told it.
It will completely forget the instructions you gave it at the beginning of the prompt. So, the architect must treat natural language like a complex, highly optimized code base. They might be masters of context window orchestration.
That sounds intense.
It is. They exploit what we call the primacy and recency effects in machine learning. This means they mathematically weight the prompt by placing the most crucial, unbreakable constraints at the very beginning, the primacy, and repeating them at the very end, the recency.
Ah, so sandwiching the instructions.
Yes. If they don't do this, the AI will forget its assigned personality 15,000 words into a conversation.
It is like trying to keep a plate spinning, but the plate is an entire artificial human personality.
That's a great analogy.
And they don't just write a massive block of text. The architect uses modular prompt design. They define global variables, like the overarching tone or the demographic of the target audience. They establish rigid negative constraints, explicit bulleted lists of concepts the AI must never mention under any circumstances.
And they even build sequential logic loops using if-then statements.
Like actual coding.
If the user expresses frustration with the product, transition immediately to narrative state Y, bypass the standard apology, and offer solution Z. It is literal software programming, but the programming language is conversational English.
So that is the architect building the structure. The second persona is the psychologist. And honestly, this is where the source material gets a little eerie to me.
Eerie is the right word.
Because to make the AI sound indistinguishably human, the engineer has to deeply understand human psychological flaws and artificially map them for the machine. They build what the source calls a deep persona synthesis.
They don't just type act friendly.
No. They define the AI's childhood backstory, its core philosophical beliefs, and its flawed but relatable character traits.
Because perfection is inherently non-human. If an AI never makes a mistake, it sounds robotic. The psychologist utilizes cognitive empathy mapping.
Cognitive empathy mapping.
They anticipate how the human reader will feel at different stages of the resulting text, and they write strict instructions that force the AI to validate the reader's unspoken anxieties. They explicitly program the AI to inject vulnerability into its responses.
Yes. The text says the engineer instructs the AI to occasionally admit uncertainty, to use self-deprecating humor, And even to deploy conversational fillers like, or I
They
mean.
are manufacturing the messy, imperfect reality of human connection out of pure math.
It's wild. And then you have the third persona, the master rhetorician. This is the literary artist. Because holding a human reader's attention for a long duration requires advanced narrative design.
Right.
The rhetorician uses psychological hooks like open loops, where they force the AI to introduce a highly compelling concept in paragraph 1, but strictly forbid the AI from resolving it until paragraph 6, which keeps the reader yearning for the payoff.
It's classic storytelling mechanics.
Exactly. They explicitly command the use of the rule of 3 for rhythmic cadence. They calibrate the musicality of the voice, filtering the vocabulary to ensure the microtones of the words project warmth instead of corporate condescension.
When you step back and look at these three personas combined, the architect's rigid logic, the psychologist's manufactured empathy, and the rhetorician's narrative manipulation, you begin to understand the intense characteristics required of the prompt engineer themselves.
It's a lot of pressure.
Obsessive iteration. Relentless debugging, spending 3 hours tweaking a single sentence in the prompt to fix a cascading emotional error in the output, and what the text refers to as radical empathy.
Radical empathy.
You cannot program empathy into a machine if you do not possess a profound, nuanced understanding of it yourself. The conclusion of this elite guide is almost poetic. It says, operating at this maximalist level means you are effectively ghostwriting the soul of the machine.
Ghostwriting the soul of the machine. It is an undeniable achievement in systems thinking. It proved that language models can be sculpted into incredibly complex psychological mirrors.
It really does.
It's a massive achievement. But as I was reading this source, as I was marveling at the sheer, overwhelming effort required to build a 20,000-word emotional labyrinth just to make an AI sound like a relatable coworker, I couldn't help but ask myself, is there another way?
A different path entirely.
Yeah. A way that feels less like ghostwriting a soul and more like the disciplined, rigorous CAD engineer who just wants to build a toy that doesn't break.
This raises an important question, and it brings us to the most radical thematic shift in our source material. Because there is another way. It is a massive polar opposite counter-approach.
The complete opposite.
And it is built entirely around the philosophy of the industrial designer Dieter Rams.
Yes. The Dieter Rams system prompt. For anyone listening who might not be familiar, Dieter Rams is arguably one of the most influential industrial designers of the 20th century. He was the chief design officer at Braun. His minimalist aesthetic heavily influenced Apple's hardware design, and his entire ethos is summed up in 3 simple German words, weniger, aber besser.
Less but better.
Less but better. And one of our primary sources is a system prompt designed to govern an AI strictly by this philosophy. Instead of the maximalist 20,000-word psychological labyrinth, it applies the absolute minimalist constraint.
It's the ultimate antidote to slop.
But I need to challenge this because we have a massive clash of philosophies in our sources right now.
Let's hear it.
Okay, the elite prompt guide we just talked about explicitly instructed us to use the rule of 3 for cadence and to inject conversational fillers, warmth, and self-deprecating humor so the AI sounds authentically human. But the Dieter Rams prompt explicitly and aggressively bans all of those things.
It does. It forbids them.
So what if I am building a customer service bot for my banking app? Don't I want that bot to have conversational fillers so the stressed-out customer feels heard and validated? Won't pure brutalist efficiency make my customers hate my brand?
That is the exact tension the sources are exploring. The Elite Guide fundamentally wants the AI to act as a companion. It wants the AI to hold your hand, make you laugh, and validate your feelings.
Right.
But the Dieter Rams philosophy is violently opposed to anthropomorphizing the machine. The Rams prompt treats the AI strictly, unapologetically as a tool.
A tool.
A tool is not your friend. A hammer does not tell you a warm, self-deprecating joke before it drives a nail into the wood.
That's a great point.
If your banking customer is stressed, Rams would argue that solving their financial problem in 3 seconds with perfect accuracy is vastly superior customer service than making them read 2 paragraphs of manufactured digital empathy.
It is pure brutalist efficiency. Let's break down the operational rules imposed on the AI by the Dieter Rams constraints, because honestly, reading them was a breath of fresh air.
They are so refreshing.
Rule 1 is utility first. Prioritize function over form. The prompt commands the AI to answer the core problem immediately in the very first sentence. Form follows function. If a sentence doesn't directly help the user achieve their goal, delete it.
Rule 2 is restraint and neutrality. The system prompt literally commands the model, You are a tool, not a companion. Remain completely unobtrusive.
Unobtrusive. I love that.
It forbids enthusiastic affirmations. It bans introductory pleasantries. Hi, I'd be happy to help you with that complex data analysis.
Yeah.
Gone.
Good riddance.
And crucially, it forbids those decorative, repetitive conclusions. You know how an LLM always wants to wrap up a perfectly good answer with, in conclusion, whether you are a beginner or an expert?
Yes. The endless repetitive summaries that add absolutely zero new information. The RAM's prompt actively kills them.
Rule 3 is absolute clarity. Make complex explanations self-explanatory. And there is a brilliant nuance here. The prompt instructs the AI that if a concept is highly technical, it must break it down to its simplest moving parts without dumbing it down.
That's a tough balance to strike.
It is. But clarity does not mean condescension. It means removing the linguistic friction.
Rule 4, honesty and precision. State limitations plainly. Do not overstate capabilities. And this sentence from the source is just incredible. Treat accuracy as a form of respect for the user.
Let me build on that because that is the CAD engineer mindset applied directly to text.
How so?
Respect is not warmth. Respect is not a smiley face emoji or a friendly greeting. Respect is delivering mathematically precise accuracy so the user can trust the structural integrity of the information.
Wow. Yes. And finally, Rule 5, which is undoubtedly the most entertaining part of this entire deep dive, timelessness and banned vocabulary.
The banned words list.
The prompt forces the AI to avoid trendy internet jargon and hype. But it goes so much further. It provides a strict, explicit list of forbidden words. These are the crutch words that AI uses constantly to sound profound, which actually just create that slop we diagnosed earlier.
This list is critical. If you read AI-generated text or corporate memos regularly, you will recognize these words instantly. They are the hallmark of lazy thinking.
I'm going to read this banned words list, and I want you, the listener, to do something for me. Open your sent folder in your email right now. Search for these words. Think about how many times you used them this week to sound professional.
Prepare to be humbled.
The banned words are delve, tapestry, vibrant, crucial, showcase, testament, pivotal, underscore, seamless, foster, elevate, landscape.
A vibrant tapestry of seamless landscapes.
Ugh.
It is a nightmare of meaningless syllables.
It's the ultimate slop. You thought you were adding value by saying seamless integration, but you were actually just adding friction to your coworker's day.
Exactly.
The prompt also explicitly forbids negative parallelisms. You know, the classic political speech structure, it is not just about X, it is about Y. It forbids the rule of 3 when used just to pad descriptions, so no more saying a product is fast, secure, and reliable.
Because if it's not actually fast, secure, and reliable, you're just padding.
Right, and it demands the use of basic active verbs. It says use is or are instead of filler phrases like serves as, acts as, or represents.
This raises an essential mirror to our own communication habits. How often do we pad our presentations or our prompts with words like tapestry and delve just to unofficially inflate our perceived intelligence?
All the time.
We think complexity equals value. Dieter-Rams proved that pure utility is the ultimate sophistication. When you strip away the conversational filler, the emojis, the tapestry of nonsense, what you are left with is the pure, hard signal of truth.
So if we adopt this Dieter-Rams approach, this philosophy of pure, unadorned utility, the question then becomes, how do we actually construct a prompt that achieves it without writing a 20,000-word novel?
Which brings us to the operational phase. If we want Rams utility, we have to return to the rigor of the CAD engineer.
Back to the beginning.
Specifically, step 2 of the CAD process, define. Be precise. Do not leave room for the AI to guess the parameters.
Because an AI left to guess will always guess slop.
Always. It will revert to the mean.
Our sources provide a masterclass in how to define these parameters with a framework called the 5-layer prompt framework. And they use a specific visual generation example that makes the difference between a bad prompt and a great prompt mathematically undeniable. They call it the one-line fix.
The contrast they show is stark and highly illustrative.
Let's look at the lazy prompt. The user just types, a woman holding a skincare product.
We all know exactly what that output looks like.
We do.
It is aggressively generic. The lighting is flat and artificial. It looks like a cheap stock photo from 2014. Because the user did not define the constraints, the AI had to guess about the environment, the camera lens, the mood, the color palette, and the subject's age. And it guessed the most statistically average elements possible.
Now listen to the expert prompt using the 5 layers. A 28-year-old Indian woman holding a luxury serum bottle, soft golden hour lighting from the left, shot with a Canon EOS R5, 85mm f1.4 lens, Shallow depth of field, warm amber and cream tones, dewy skin texture, editorial beauty photography, 8K ultra realistic.
The difference in the output is night and day.
It has to be.
The result of that prompt is a high-fidelity, studio-quality brand asset. And it is entirely because the user eliminated the algorithm's guesswork across 5 specific technical layers. Let's break those layers down, because they are a blueprint for absolute clarity.
Layer 1, subject and action. We didn't just say a woman. We defined the demographic and the specific object. 28-year-old Indian woman holding a luxury serum bottle. Specificity anchors the image.
Layer 2, environment and lighting. This is critical for visual realism. Soft golden hour lighting from the left. You must tell the neural network where the light source is originating, because that provides the necessary shadow and highlight data that tricks the human eye into perceiving a flat image as three-dimensional.
Layer 3 is the most fascinating to me, camera and lens. Shot with a Canon EOS R5 85mm f1.4 lens, why are we telling an artificial intelligence a literal line of code about a physical piece of glass?
Because you are commanding the neural network to mathematically mimic the physics of real-world optics.
Okay, break that down for me.
An 85mm lens at an aperture of f1.4 naturally creates a very specific shallow depth of field. The background blurs out smoothly into bokeh, and the subject's face remains in razor-sharp focus. You are using physical parameters to force the AI to direct the viewer's eye exactly where you want it. You are manipulating the latent space distribution to recreate reality.
It's the CAD define stage. We aren't just saying make the background blurry, we're defining the focal physics.
Exactly.
Layer 4 is color and texture. Warm amber and cream tones, dewy skin texture. This provides the tactile feel.
It connects right back to the CAD engineer designing for the hand. You are trying to make a digital matrix of pixels feel like a physical, tactile reality that someone can almost touch.
And Layer 5, style and quality tags. Editorial beauty photography, 8K, ultra realistic. This sets the final stylistic reference point for the model's dataset. This 5-layer framework is a perfect, practical application of what the AI blueprint calls the 3 C's of prompting.
The 3 C's are the foundational pillars of the Dieter-Rams approach. Be concise, be clear, be consistent.
I want to drill down into be consistent, because the text provides a very specific example about vocabulary tokenization that is so easy to mess up, and it completely ruins the output.
Consistency is about respecting the machine's literal nature. If you refer to a set of data as a spreadsheet in your initial prompt, you must continue to call it a spreadsheet for the entire duration of that conversation.
That sounds simple enough, but we mess it up all the time.
We do. If you casually switch your vocabulary in paragraph 3 and start calling it a matrix or tab, a human would easily understand from context that you mean the same thing.
Right.
But the AI assigns different token values to those words. It might suddenly assume you are introducing a completely new, parallel data set, and the internal logic breaks down.
It's exactly like changing the core dimensions of the toy helicopter halfway through the CAD process.
Right.
It corrupts the entire model. The final structural technique the sources offer to maintain this consistency is called prompt chaining, or the assembly line approach. And the core rule here is, don't ask for everything at once.
Which goes back to the concise rule. If you give an LLM a massive, complex, multi-step cognitive task in a single prompt, it will cut corners, it will drop instructions, it will hallucinate facts, and it will give you slop.
The source gives a highly relatable example of planning a travel itinerary. Instead of dumping a prompt that says, plan a 14-day trip to Europe with historical art sites, a food budget, and daily schedules, you break it into a logical assembly line.
Step by step.
Prompt 1 suggests 10 well-known historical art sites in Europe. The AI completes that specific task. Then you review it. Prompt 2. Using only those exact 10 locations, create a logical day-by-day itinerary that mathematically minimizes train travel time. The AI does that. Then prompt 3. For each specific day, suggest 3 highly rated restaurants within a 1-mile radius of the scheduled art site.
You are acting as the general contractor. You build the foundation, verify it is level, frame the walls, verify they are plumb, and only then do you put on the roof. You maintain absolute control of the logic at every single step of the chain.
So we have empathized with the chaos of the user. We have defined our precise problem. We have applied our brutal Dieter-Rams constraints. We have built our 5-layer prompt, and we have chained our logic. But if we want to truly adopt the mindset of the elite CAD engineer, we have one final, non-negotiable step before we deploy this work.
We must return to step 5 of the CAD product development process. Test, Give it to reality.
Exactly. Wait, let me rephrase that. You are entirely correct. You cannot just blindly accept the output, no matter how perfectly engineered the prompt was. In the digital world, this final testing phase is formally known as keeping a human in the loop.
Because as the Responsible AI Best Practices document explicitly states, AI lacks real-world experience, it lacks moral context, and it lacks common sense. It is not a substitute for professional human judgment. It is a rapid collaborator, not an infallible calculator.
To enforce this human-in-the-loop reality testing, the sources provide a very clear framework called the ACT checklist, ACD, and this should be your daily cheat sheet for professional integrity. The A stands for ask. Before you even begin, you have to ask yourself, is AI even the right tool for this specific task? If you are dealing with nuanced medical, legal, or financial advice that requires a human license and ethical liability, the answer is no.
And crucially, under that ask umbrella is the data safe. You must never, under any circumstances, input confidential, proprietary, or sensitive personally identifiable information into a public AI tool. Once it goes into the model, it becomes part of the training data.
And the text gives highly practical ways to protect that data if you still want to use the tool for formatting. Use generic placeholders, swap real client names for Project X or Client A. Frame the prompt around the structural tasks required, not the specific people involved.
That's a great tip.
And importantly, clear the AI's active memory before starting a new task. Give it a clean slate to prevent contextual bias from old prompts bleeding into new work.
Then we move to the C in the checklist check. You must independently verify all facts for accuracy. Watch out for those subtle, highly confident hallucinations we discussed earlier.
You can't just trust it.
Never. You must evaluate the output for unfair bias. You must check it for appropriateness. Does the tone actually match the demographic of the audience, or did it generate slop?
And finally, the tell. Be transparent. Tell your team, your clients, or your readers when you use AI to fundamentally help generate content, and remain strictly compliant with your company's governance guidelines.
If we connect this to the bigger picture, all of this effort, the rigorous checking, the masking of proprietary data, the transparent disclosure building an auditable trail of how the AI was utilized isn't just bureaucratic busywork.
No, it's not.
It is the very definition of professional integrity in the modern era. When the project ships, when the plastic toy hits the retail shelves, when the quarterly email goes out to the board, you cannot blame the tool if something goes wrong. You must own the final deliverable.
So what does this all mean? We have covered an incredible amount of intellectual ground today. We started in the physical realm of computer-aided design, imagining the structural tolerances of a toy built for the chaotic hand of a child.
The true test of reality.
We explored the digital epidemic of AI slop and the maximalist 20,000-word engineering efforts required to ghostwrite a machine's soul. We pivoted to the brutal, beautiful minimalism of Dieter Rams' less but better, with absolutely no tapestries delving or seamless landscapes allowed.
We finally banned those words.
Thankfully.
Yeah.
And we learned how to engineer precision through 5-layer frameworks, assembly line chaining, and relentless reality testing.
The synthesis of all these diverse sources is incredibly empowering. It serves as a reminder that whether you are using complex CAD software to injection mold a product, or you are utilizing the most advanced large language model to map a workflow, the tool is never the designer.
Right.
You are the designer. Empathy for the end user, clearly defined problems, radical constraints, and rigorous testing against the friction of reality are the only things that separate disposable digital slop from enduring tangible value.
The machine can generate the text, and the software can render the geometry, but neither of them can generate the intention. To leave you, the listener, with a final provocative thought to mull over as you go back to your own powerful tools and your own blank pages. There is a single piercing question posed at the very end of the AI blueprint document. It is a question about the hidden cost of relying too heavily on the machine without understanding the foundation of your own expertise.
The document asks this: what was the first data set you threw away, and what did that cost you?
A haunting question. What human intuition, what messy, flawed, real-world empathy did you discard because the algorithm offered you something cleaner, faster, but ultimately hollow? Thank you for joining us on this deep dive. As you move forward this week, remember to do the hard thinking before you open the software. Remember to design for the hand, not for the screen. And when in doubt, just remember, less, but better. We'll see you next time.